Hey everyone, Mr. Marquardt here again, working you through A.1.6. We're going to continue working with simplifying our algebra tiles and then figuring out which expressions are greater. But before we do that, a couple announcements. So again, tomorrow, since today is Tuesday, Wednesday, we have a formative quiz on all the stuff from the appendix we've covered so far. So A1.1 through A1.4. This Friday, we've got our homework collection for A1.5 through A1.7. So be on the lookout for all that stuff. Make sure you're checking this learning tomorrow so you can take that quiz. All right, so the plan for today, checking our homework answers from last night. And we've got just a couple problems to do in class, doing more or less the same thing we did yesterday. So if you want to check your homework answers, make sure you pause the video. Make sure you get the different sections here. And we should be good. If you have any questions on any of the homework problems, please reach out to your grading teacher and let us know. So yesterday we started talking about which is greater in terms of quantities on our expression mats, and we're going to continue doing that today. So when we are talking about our legal simplification moves that we talked about yesterday with Mr. Myers, there were 3 different things that we could do. So the first thing was we could cancel our zero pairs. We could cancel our zero pairs. We could remove like tiles from both mats. And then last thing was we could, let's put 3 over here, we could move tiles on our mat. Oops. Move tiles to the positive region on our maps. We can see what's going to cancel, what's not going to cancel a little easier. And remembering that we have to switch our values, we do number 3, moving tiles to the positive region. So let's start by doing A together. So, and the first thing we want to look for is our zero pairs. So with our zero pairs, again, we are going to have a positive tile and a negative tile in the same region. So as we look at A, we've got these 2 X tiles are going to cancel. That's a zero pair. We've got these 2 X tiles are a zero pair, so those are going to cancel. So now what we can do is we can start moving some tiles around so there's no other zero pairs on our different expression mats here. So if we move this guy up, if we move this guy up, we would get 2 more white squares because again we have to change the color of them when we slide this up. So we're left with, for this one, is a -4. We have 1, 2, 3, 4 of our -1 tiles. And then for this one, what we can do is move that positive X tile up, remembering that we have to flip it, so we are left with a white X tile there. And now, look at that. It's like Christmas comes early. We've got a zero pair. We can cancel that. And then if we also move this tile up, we are left with that 1 shaded square after we flip it over because we moved it to the other side of our mat. So we have a -4 and a 1, which is what this one is equal to, and 1 should be greater than a -4. 1 should be greater than -4. So let's move on to part B. Again, we're doing the exact same thing. We want to figure out which expression is greater. So let's start by canceling some zero pairs. Start by canceling zero pairs. So we have a zero pair of X tiles right there. We've got a pair of 0 tiles right there. Got a pair of 0 tiles. Now, something that we have in this one that we didn't before, in the positive region in both the left and the right, we have a positive X tile. So that is a like term in both expression mats, so we can move those out, and it doesn't change the value of what's left. All right, so now that that X tile is moved out of our left, all we have left are our positive 2 unit tiles. So this one is going to be worth 2. We can take this tile, slide it up, but we have to remember to flip it over. So it'll give us a shaded in unit tile. And now that makes a zero pair, so we can cross that one off of our list too. So now we are left with this -1 unit tile. So this whole thing will be worth -1. And then hopefully we all know that 2 would be greater than -1. All right, let's keep cruising to part C. So again, the first thing that we want to do is look for our zero pairs. So positive and a negative tile of the same size in either region, we can cancel those out because it's going to equate to 0. So what we have in this one, we have a 0 pair, we have a 0 pair, those can kind of cancel. We've got one down here that'll cancel. We've got one down here, 0 pair there, and another 0 pair up here. So all of those tiles are pretty much going to go away. So next, let's look at some stuff that we might be able to move up to the top part of our different tiles. So let's start by moving these two Y tiles up to the top positive region of this left side. So I'm going to try to draw these in here. So we're going to have one negative Y tile, then we're going to have two minus Y tiles after we move those up. So when we do that, we create a 0 pair with our Y tiles. So one of those is going to cancel. And then we can also move this tile upwards. So that will make another negative unit tile there. So now, when we see we have a negative Y here, and we have a negative Y tile in the positive region in our right expression mat, we can take both of those terms because they are like terms in either mat, and we can pull those out, so we can say that those are more or less gone now. And then lastly, we can move these two positive tiles up. So we're going to get two more negative tiles up on the top. So basically what we're left with when we go back to the left mat is two of our -1 unit tiles. So this one is worth -2. Over here we have -1, -2, -3 unit tiles left. So when we think about, again, on a number line, how we figure out which negative number is greater, if we've got 0 here, and we have the greater numbers to the right, and then we have the lesser numbers over here, -1, -2, -3. -2 is further to the right on this spectrum, so we know that -2 is going to be greater than -3. Good. If you have any questions, please let us know. Otherwise, we're going to keep moving on to part D. Again, more of the same. We want to start with our 0 pairs. Then we want to see if we have any like terms. Then we want to move stuff around if we can. But we'll start again with our 0 pairs. So 0 pairs. We've got X's right there, make a 0 pair. That's all I think we got for 0 pairs for part D. So now let's see if we've got stuff that we can move. Let's see if we can got anything that we can move. So let's move this x squared tile up on top here. So when we do that, we'll have a big positive x squared, because this is a minus x squared down here. We got to flip that value. We can also take our x tile, move it up. When we do that, we would get a negative x up on the top there. So this would make a 0 pair, and those x's go away. We still have to, on the right, move our two negative unit tiles up. So that would make two positive unit tiles up on the top here. If I can shade those in real quick for everybody. So on the right, now that everything's moved up, we got all of our 0 pairs canceled. Well, not quite yet, because we're still missing one thing. Is that we now have a positive x squared over here. We have a positive x squared over here. So if we take those out, those are like terms. So now we have everything taken out of the right side. So our right expression mat is going to be worth a +5. So now we can take what's left on the left and move it up, which would be this negative unit tile. Move that up to the top half. So when we do that, we flip it over. And now we are left with 1, 2, 3, 4 positive squares. And hopefully we, again, all know that 5 is greater than 4. 5 is greater than 4. So we got a couple more to do. We've got E and F. Again, we're looking for the exact same thing, zero pairs, like terms, and then moving things from the bottom to the top so we can see what's going to cancel out a little bit easier. I'm going to let you do these on your own, but I'll give you the answers so that you know that you're doing everything right. So for this one, we should end up with a minus 2 and a minus 2, which is going to tell us that these two are equal to each other, because if they're the same, either one's going to be greater than or less than the other. So make sure you check your work. -2 is equal to -2 for part E. For F, we should get 0, and then we should get 3. And again, 3 is going to be greater than 0. All right, and then the last one for the day is 60. So we want to simplify these expressions. Using the legal moves that we developed in A.1.5 and that we've been using a bunch already as we've gone throughout the video. And we want to see which of these expression mats, again, is going to be greater. So let's do that. So let's start with our zero pairs. What can we cancel? So we've got, this is a zero pair. This is a zero pair, which goes away. Perfect. So now we can move all of these different unit tiles up to the top. Let's do that next. So when we do this, we'd have one extra minus unit tile here. Over here, when we move all 6 of these positive tiles upward, that means that we would have 6 more minus unit tiles up on the top here, which hopefully that's clear enough for everybody to see. Now let's look for some like terms that we might be able to get rid of as well. So we've got an x, positive x here. We've got a positive x here. So let's yank those out. So now let's figure out what we got left. So over here on the right, we've got 2 positive x's. We've got minus 2 unit tiles. And then over here, we've got minus 8 of our unit tiles over here that's left over. So what we want to try to figure out next is which one is greater. So which one is greater? Given what we know here, are we able to tell which one of these two quantities is going to be greater? And what I'm going to say is that looking at these two quantities, we don't know which one's going to be greater because we don't know what that x value is. So can we tell which expression is greater? And again, looking at this, we don't know which one's going to be greater because we don't know what x is equal to. We don't know what x equals. If we know what x is going to be equal to, then we can plug that value in for x, and then we can tell if this quantity is going to be greater than, less than, or equal to -8. But until we know that, we have nothing else we can do with this problem. All right, so the last thing I've got for everybody today is, again, a reminder that the homework is A.1.6, which is 61 through 66. If you've got any questions, please let us know. Come to office hours, stop in and chat with us. Let's hope you guys have a great rest of your Tuesday, and we'll see you in class on Thursday.